Dear student, in this video we are going to study the nitrofuran derivatives. The first nitro heterocyclic compounds to be introduced into the chemotherapy were the nitrofurans. Three of these compounds, that is nitrofurazone, furazolidine and nitrofurantoin, have been used for the treatment of bacterial infections for various kinds for nearly 50 years. A fourth nitrofuran, that is Timox, is used as an antiprotozoal agent to treat trypanosomiasis and the leishmaniasis. Another nitroheterocyclic of considerable importance is metronidazole, which is an amibicidal and is used for the treatment of systemic infection caused by anaerobic bacteria. The nitrofurans are derivatives of 5-nitro-2-furaldehyde formed on reaction with the appropriate hydrazones or the amine derivatives. Antimicrobial activity is present only when the nitro group is in the fifth position. In structure, you can see the common structure for the nitrofuran derivatives in which the nitro group is present at the fifth position, which will give the antimicrobial activity. The mechanism of action for these nitrofuran derivatives. The mechanism of antimicrobial action of the nitrofuran has been extensively studied, but it is not fully understood. In addition to their antimicrobial actions, the nitrofurans are known to be mutagenic and carcinogenic under the certain condition. It is thought that DNA damage caused by metabolic reaction products may be involved in these cellular effect. The first drug from the nitrofuran derivative is furazolidine. The IUPAC nomenclature for the furazolidine is 3,5-nitrofuridine amino 2-oxolidinone. Occurs as a yellow crystalline powder with a bitter aftertaste. It is insoluble in water or alcohol. Furazolidine has bactericidal activity against a relatively broad range of intestinal pathogens include S. aureus, E. coli, Salmonella shigella, Proteus species, Enterobacter, and Vibrio cholera. It is active against the protozoan Giardia lamblia. It is recommended for the oral treatment of bacterial or protozoal diarrhea caused by susceptible organism. The usual adult dose is 100 mg 4 times a daily. Only a small fraction of orally administered dose of furazolidine is absorbed. Approximately 5% of the oral dose is detectable in urine in the form of several metabolites. Some gastrointestinal distress has been reported with its use. Alcohol should be avoided when furazolidine is being used because the drug inhibits aldehyde dehydrogenase. The next drug is nitrofurantoin. Nitrofurantoin is 1,5-nitro-2-furfuryl-diene 1-amino hydantoin is a nitrofuran derivative that is suitable for the oral use. It is recommended for the treatment of urinary tract infection caused by susceptible strains of E. coli, Enter coli, S. aureus, Klebsiella, Enterobacter, and the Proteus species. The most common side effects are gastrointestinal, which include anorexia, nausea, and vomiting. However, hypersensitivity reactions have also associated with the nitrofurantoin. A microcrystalline form is claimed to improve gastrointestinal tolerance without interfering with the oral absorption. The last drug from this category is methanamine. The activity of hexamethylene tetramine, that is urotropin or uretone, depends on the liberation of formaldehyde. The compound is prepared by evaporating a solution of formaldehyde and strong ammonia water to dryness. You can see this is the formaldehyde molecule and this is the ammonia. When these both compounds are combined and you have to allow them to evaporate, the solution will give a methenamine molecule. The free base exists as an odorless white crystalline powder that sublimes at about 260 degrees Celsius. It dissolves in water to form an alkaline solution and liberate formaldehyde when warm with mineral acid. Methenamine is a weak base with a pK value 4.9. Methenamine is used internally as a urinary antiseptic for the treatment of chronic urinary tract infection. The free base has practically no bacteriostatic power. Formaldehyde release at the lower pH of the kidney is required to optimize the antibacterial effect. An acidifying agent such as sodium biphosphate or ammonium chloride generally accompanies the administration of methenamine. Certain bacterial strains are resistant to the action of methenamine because they elaborate urease, an enzyme that hydrolyzes urea to form ammonia. The resultant high urinary pH prevents the activation of methenamine, rendering it ineffective. This problem can be overcome by the co-administration of the urease inhibitor acetohydroxamic acid. Dear students, here we ends with the urinary tract anti-infective agent. Thank you. Stay home, stay safe. Happy learning.